Hello friends, let's balance one more redox reaction by the oxidation number method. This redox reaction is given in the form of molecules, not ionic equation. This is a molecular equation. The equation for the reaction is potassium dichromate with potassium iodide in the presence of the acid, that is sulfuric acid. As a result, potassium sulfate, chromium sulfate, iodine and water are obtained. This equation we can balance by oxidation number method. First, I can note down the oxidation numbers. Here the oxidation numbers of chromium we need to find, and here iodine, and here also at the product side chromium and iodine. Iodine at the product side, this is in the free state, therefore the oxidation number is 0. Chromium oxidation number, that is chromium oxidation number sulfate charge is 2 minus, and in order to balance this chromium must have, what is that, 3 plus. Chromium, the oxidation number is 3 plus at the right hand side. Then only the charges will be cancelled, because 3 times minus 2 0, 3 times minus 2 minus 6, then 2 times 3 plus, that is plus 6, the charges will be cancelled. Therefore, chromium oxidation number is plus, what is that, 3 plus, plus 3. Chromium oxidation number plus 3, like that we need to write, plus 3. Here the iodine oxidation number at the left hand side in potassium iodide, here it is minus 1, because potassium has the oxidation number plus 1, therefore this iodine must have minus 1. In the case of chromium in potassium dichromate, potassium oxidation number plus 1, chromium we can consider 2x minus 7 times this 2, that is 14, that is equal to 0. That is 2x is equal to what is that? Here, sorry, one mistake, that is 2 potassium atoms, therefore 2 times plus 1, that is equal to 2. So 2 plus 2x minus 14 is 0. 2x is equal to 12. Therefore, x is equal to plus 6. X is plus 6. So potassium oxidation number in potassium dichromate is plus 6. Now all the oxidation number of the variable oxidation numbers we have noted here. Now we can find the decrease in oxidation number and increase in oxidation number. The first one, chromium, let's check the oxidation number, chromium first. Chromium oxidation number changes from plus 6 to, what's that, plus 3. So here what happens, there is a decrease in oxidation number takes place, decrease in oxidation number. How much it decreases? That is plus 3, the oxidation number decreases. So this reaction is reduction reaction, this reduction of reaction. The next change is for iodine atom, its oxidation number changes from -1 to 0. So here what happens, that is increase in oxidation number takes place. How many oxidation number increase? +1. So this is oxidation reaction, oxidation of reaction. Now when we check the equation, chromium atoms 2 times are there, and iodine atoms also 2 times are mentioned in the reaction. Therefore, chromium atom we need to write 2 times, iodine also we need to write 2 times. That is, this we need to write 2 times. That is, this has to be multiplied by 2 times. Similarly, this also has to be multiplied by 2 times, because 2 iodine atoms are present. Similarly, here 2 chromium atoms are present. Therefore, we need to multiply 2 times. We need to write the decrease in oxidation number for chromium, and 2 times we need to write for the increase in oxidation number for iodine. So now when we check, both are the same multiple, that is the multiples of 2, that is same number, so we can cancel it. We can cancel these 2 will be cancelled. So as a result, now the decrease in oxidation number is 3, increase in oxidation number is 1. So using this 3, we need to multiply this iodine species on the right hand side. Using this 1, we need to multiply this chromium on the right hand side, chromium species on the right hand side. So as it is 1, it's not necessary to be mentioned. So with this 3 only, we need to multiply this iodine species on the right hand side. So let's multiply here. So iodine has to be multiplied on the right hand side by 3 times. I am writing at the bottom, iodine at the 3 times, 3 iodine. So when we write 3 iodine at the right hand side, left hand side when we check, left hand side only 1 iodine. Therefore now right hand side, now 3 times 2, 6 iodine. Therefore left hand side also 6 iodine must be there. So this Ki must be multiplied by 6 times. 6 times it has to be multiplied by 6 times. So it is multiplied by 6 times. Ki is multiplied by 6 times. Now left hand side, when we check the number of potassium atom, here 6 potassium and here 2 potassium. So 6 plus 2, 8 potassium atoms on the left hand side. But the right hand side only 2 potassium. Therefore here we need to multiply 4. The coefficient 4 we need to mention before this potassium sulfate on the right hand side. So now total number of sulfate ions, sulfate, here one sulfate group is there. How many times? That is 3 times. Here one sulfate in potassium sulfate. Potassium sulfate how many times? Here 4 times. So here in potassium sulfate, here 4 times sulfate, and in chromium sulfate 3 times. Outside the bracket the subscript 3 is there. So 4 plus 3, 7 sulfate on the right hand side. But the left hand side sulfate in the sulfuric acid, here the sulfate radical is there. This sulfate only 1 time. The right hand side 7 times, but the left hand side only 1 time. Therefore, what has to be done? The sulfuric acid has to be multiplied by 7 times. So it is multiplied by 7 times. When we multiply the sulfuric acid by 7 times, left hand side, how many hydrogen atoms are there? 7 times 2, 14 hydrogen atoms. But the right hand side, only 2 hydrogen atoms therefore, in water. Therefore, this water molecule needs to be multiplied by 7 times. Now, when we check all the atoms on the left hand side and the right hand side, the number of atoms will be equal. Now, potassium right hand side 4 times 2, 8. Left hand side also 2 plus 6, 8. Similarly, chromium here 2 chromium atoms, here also 2 chromium atoms. Iodine 6 iodine, here also 6 iodine, 3 times I2, 6 iodine. Sulfate 7 times, the right hand side here 3 times, here 4 times, 7 times. Then hydrogen 7 times, 14 hydrogen, here also 14 hydrogen. So excluding this sulfate, this oxygen alone, when we check 7 oxygen atoms, here also right hand side, here 7 oxygen atoms, 7 moles of water, so 7 oxygen atoms. So all the atoms on the reactant side as well as the product side are equal. So now the equation is balanced. Thank you so much for watching.